All right, parallel lines and transversals. All right, you did some definitions yesterday, so hopefully you understand what parallel lines are and parallel planes. And we're going to talk about intersecting lines right now and transversals. So when any two lines, if this is line L and this is line M, when any two lines, when at least two lines are intersected by a third line, line L, line M intersected by line T, line T becomes a transversal. And all of these angles that are created now have names. So we're going to number these angles 1, 2, 3, and 4. 5, 6, 7, and 8. In this diagram, the relationship between these lines, in between line L and line M, this is called the interior. It's in between the two lines that are cut by the transversal. Everything outside, or everything to the top of L, that's the exterior. And everything below line M is also the exterior. So now there's some angles, relationships, names that you need to know and understand because you're going to see them throughout the rest of the year. So we're going to start off with interior angles. And in this diagram, the angles that are in the interior, or the interior angles, those are these four that are in here in this interior region. So it's angle 3, 4, 5, and 6. Those four angles are called interior angles. In that same diagram, there's four exterior angles. All right, and those are 1, 2, 7, and 8. All right, the next type of angle or name of angle is called consecutive interior. Consecutive interior. Consecutive meaning, in this case, on the same side. On the same side of the transversal and on the interior. So a pair of consecutive interior angles here would be 3 and 6. And the other pair of consecutive interiors would be 4 and 5. Consecutive interiors are on the same side of as the transversal. And alternate interior, those are on alternate sides of this transversal. So a pair of alternate interior angles here would be 3 and 5. And the other pair would be 4 and 6. Everybody all right with that? Next type of angles, alternate exterior angles. Alternate sides of the transversal, but in the exterior. So that would be 2 and 8. And what's the other pair? 1 and 7. All right, last type in this diagram, corresponding angles. They hold the same position. In their respective group. Corresponding angles hold the same position in their respective group. What that means is, do you see how you have this group of 4 angles up top? And then do you see this group of 4 angles below? Each time 2 lines intersect, it forms 4 angles. So you got a group up top. I'm going to call this group A. I'm a group on the bottom called group B. Corresponding angles hold the same position in their respective group, in their respective groups. Make that an S. So the first pair of corresponding angles, what angle looks like it corresponds to angle 1? It's in the same position, but a different group. Yeah, 1 and 5. So 1 and 5. They're both in the upper left portion of their group of angles. So 2 and 6. 3 and 7. And the last group of corresponding angles in this picture, 4 and 8. Very good. Any questions on those groups or different type of angle names? All right, so then let's draw this box here. And then we're gonna draw it in 3 dimensions. We'll label all these vertices. And we're going to say identify the following. All right, first thing we're going to identify here. Segments. Here's the symbol for parallel, just two parallel sticks, segments. Segments parallel to BC. Segments parallel to BC. Anybody give me a segment that's parallel to BC here? Good. AD. AD is parallel to BC. They don't intersect with each other. Anything else do you see? See FG on the bottom back of this box? FG is parallel to BC. This front bottom edge, EH, that's also parallel to BC. Anybody not see that? All right, parallel lines are in the same plane, they don't intersect. Same plane, don't intersect. Skew lines, if we're looking for skew, segment to BC. Skew lines, they don't intersect either, but they're in different planes. So a segment or a line that's skewed to BC. Here's BC, still in the upper back. All right, this AE is skew to BC. In 2 dimensions, they would intersect right up here somewhere. But in 3-dimensional, they don't intersect. This is the front left corner of the box, and this is the back top edge of the box. So another segment, skew to BC. DH. Another one, skew to BC. That could be EF. And one more that's skew to BC. HG, good. All right, so that's parallel, that's skew. Those are segments. Planes, parallel to ABC. ABC is the top of this box. Right up here. What's parallel to the top of the box? The bottom of the box, good. And when you're describing a plane, you need to use 3 points that are not on a line. All right, so if we want to describe the bottom of this box, we can use EFG. Those would be 3 points, EF and G, that are in the plane, but they're not on the same line. All right, so parallel to ABF. What's a plane parallel to ABF? Say again. DCG, good. DCG, so you got left side parallel to right side. All right, front of this box, would be, you could describe it as ADH, parallel to ADH. BCG, you could call it CGF, you could call it FBC. Any 3 points in the plane, but not on the same line. All right, any questions on any of that stuff? All right, your assignment for today then. It's on page 176. Page 176. Maybe like one person from each row can go up there and get some books. We're going to do 13 through 30 today. 13 through 30. Page 176. 13 through 30.